All right, so we are going to go ahead and get started with our density lab. Notice we have a few items. We have our digital scale, and we will use that here shortly. And we have 3 unknown materials and blocks, and we have 2 cylinders, numbers 4 and 5. We have 2 graduated cylinders with different colored volumes of water, and we have our ruler here. The last thing that you will need, of course, is your data sheet. So we'll go ahead and get started. We're going to be working with block number 1 first, and how this is going to work is I'm going to show you the dimensions of the block using this ruler, and then you are going to calculate your volume. After you find your volume, I'm going to mass each of the blocks using our scale here, and then you'll have your volume and your mass, and you can go ahead and calculate your density. We'll go slowly, and that way you can have time to calculate volume and find your mass and then find your density, and hopefully you can identify your unknown metals. So let's go ahead and get started with block number 1. I'm going to move this down a little bit. Block number 1, you can see when I measure it, it is a cube. It's a perfect cube, and on one side the length goes to right there. So I'm going to move this a little bit for you. You can see that a little bit better. So here is one side of our cube. Okay, so that should help you figure out your volume. We know that the formula for volume is big B little h, and big B stands for the base, which is length times width, and then you'll have your height. So go ahead and take a second to calculate your volume and put that into your answer document. There is a spot where you can put your length, your width, and your height for each item, so go ahead and make sure you take care of that. When we count mass here, you'll put your volume there, and then you can calculate your density, and then we're going to identify our block using our chart of common densities. All right, so you should have your volume calculated. We're going to go ahead and mass this. We're going to turn on our scale. I'm going to put this down a little bit so you can see. I'm going to turn this light off, you can see even better. All right, so we're going to weigh our block 1. Block 1 weighs 44 grams. So please go ahead and write that information down and mass for block 1. 44 grams. We'll go ahead and take that off. So now you have your volume for block 1. You have your mass for block 1. Take a second to calculate your density, and go ahead and put that in your answer document. And then if you would, take a second and look down at the bottom at the chart of common densities between objects. I'll turn this light back on. You can see a little better. Well, it looks like you can probably see just as good when it's off. So take a look at that chart of common densities and see if you can figure out what is block 1. What element is block 1? What material? All right, so let's go ahead and move to block 2. Block 2, you'll notice go ahead and put that there. Block 2 is also the same dimensions as block 1. So block 2 has the same dimensions as block 1. It has the same length and width and height, if you wanted to check that out. Okay, so go ahead and take a second to calculate your volume of block 2. You should come out with the same answer that you did on block 1. Both of those blocks take up the same amount of space. That's the definition of volume. Volume is the amount of space that an object takes up. So we're going to go ahead and turn on our scale so we can mass block number 2. Looks like block number 2 is going to come in at 145 grams. So go ahead and write that down if you would. Block number 2, 145 grams. So at this point, you should have your mass for block 2. You should have your volume for block 2. Go ahead and calculate your density. Give you a second to do that. And then take a look at your chart of common densities to see what material block 2 is made out of. Got 6 different options there. All right, let's go ahead and move on to block 3. Block number 3. We are going to measure block 3. You'll notice there's a trend. Block 2 and 1 and 3 are all the same dimensions. They have the same physical dimensions. So go ahead and calculate that. Remember big B, little h, which is our base, which is our length times our width, and then times our height. This is a cube, so they have the same dimensions on all sides. Put that volume into the space provided for block number 3 on your lab density data sheet. Let's go ahead and mass block number 3. Block number 3 comes in at 9 grams. Block number 3 is 9 grams. Go ahead and record that information into your data chart. So now you have the mass for block 3. You also have the volume for block 3. Take a second to calculate its density. And then if you would, go ahead and record that, and we'll take a quick look back over here at our common chart of densities. Okay. Excellent. I do just want to point out one quick thing. You know, all 3 of these blocks, they are the same dimensions. So based on the fact that they have different masses, you know, block 1 and then our block 2 and block 3, all right, we know that they have different masses, but they take up the same amount of space. So we know that there's a different amount of material or matter in each block. So the more matter that something has in a defined space, we know that it has a higher density. A higher density. So all 3 of these blocks together happen to weigh 198 grams. So that's the block portion, or cube portion of our density lab. Now what we're going to move to is our how to find the volume based on water displacement. We're going to be using these 2 graduated cylinders. In this graduated cylinder on the right, there is 10 milliliters of colored water. And this graduated cylinder on this side, there's 15 milliliters of colored water. So the first thing we're going to do is we're going to mass out our 2 cylinders. We have cylinder number 4 and cylinder number 5. Notice they are a little bit different in size. That number 5 is a little bit taller. But let's go ahead and look and see what our mass is. So our mass for cylinder number 4 is 45 grams. The mass for cylinder number 4 is 45 grams. Go ahead and record that on your data sheets. And we are going to put this cylinder number 4 into our graduated cylinder that has 15 milliliters of water. So I'm going to slide this one out of the way, and I'm going to gently tilt this over so I don't spill any of our colored water. Let that gently go down. Small bubble there on the side. All right, there we go. All right, so we have a new volume. I'm going to zoom in to see if you guys can see that any better. It may be kind of difficult to read. In fact, it is difficult to read. I'm looking at the screen now. So I'm going to give you the reading, and it went from 15 milliliters to 20 milliliters. So our initial volume, or our starting level, for cylinder number 4 was 15, and our final level is 20. So please go ahead and calculate your volume for cylinder number 4. And we had the mass for cylinder number 4 as well. So go ahead and calculate your density for cylinder number 4. I'm going to move that out of the way. Once you calculate your density, go ahead and take a look at your chart. I'm going to turn this light back off. There we go. And take a look at your chart of common densities and see if you can figure out which unknown metal is cylinder number 4. All right. Now we're going to go ahead and move to cylinder number 5. So we are going to start out with cylinder number 5. We're going to mass this comes out to 18 grams, cylinder number 5. The mass is 18 grams. Go ahead and record that onto your lab data sheet. 18 grams, cylinder number 5. That's our mass. And then what we're going to do is we are going to put this cylinder into our graduated cylinder that had 10 milliliters to start off with. And I'm going to do the same thing. I'm going to tilt it over so it slides a little bit better in there. We don't make a big mess. All right, excellent. So let's take a look at our new height. And it looks like our new height is going to be 16.5. So 16.5 is our final level. We started at 10 milliliters and our final level is 16.5. So if you would, go ahead and record that data into your lab sheet. We'll take a look at that one more time. Now you do have some options to choose from here. We have steel, which is 8.1 grams per cubic centimeter. We have wood pine, which comes in at 0.5. We have aluminum, which is 2.8 grams per centimeter cubed. Copper is 9.2. We have PVC at 1.6 grams per centimeter cubed. And brass at 8.7 grams per centimeter cubed. So we have a few things to choose from. What we're going to do now is